Okay. Okay, so we're gonna do our phase shift. So obviously the amplitude is still 1, the midline is still the x-axis. What's my period?
2.
That's what B is. What's the period?
Which is
2 pi over 2.
2 pi over B.
Oh, yeah.
So that it's gonna be 2 pi, in this case it's 2,
which is just pi.
which is gonna give me a period of pi, which what does that mean?
It just ends at pi.
It's gonna go from the starting point to the ending point, it's gonna cover a distance of pi. But it's not gonna start at 0 this time, because I have this minus 2 pi over 3.
Which means it's going to start.
Don't say it. We have to have our phase shift. And the way we find the phase shift is I take the entire parentheses, this whole section, 2x minus 2 pi over 3, and I'm going to set that equal to 0. I take everything in there and I set it equal to 0. Okay? Then I'm going to solve for x. That's the only thing new today. Take everything in the parentheses and solve for x. So I would add 2 pi over 3. I get 2x equals 2 pi over 3. How do I get rid of that 2?
Divide.
Divide both sides by 2 or multiply by 1/2, either way. Multiply by 1/2, so these cancel. X is going to be equal to 2 pi over 6, which is pi over 3. And that's my new starting point. Okay? Now, let me show you how that relates back to the equation I just gave you. Okay? Let's take this inside the parentheses and let's factor out a 2. If I take a 2 out of 2x, what am I left with?
X.
X. Minus if I take a 2 out of 2 pi over 3, what do I get?
Pi over 3.
Pi over 3. So I could factor and find the phase shift that way. I find that when we get a little more complicated equations, it's easier to just take the whole thing set equal to 0. Okay? But that's how you would do that. Okay, so that means my phase shift is at pi over 3. So this is my new starting point. Everything else is the same. Okay? So let's go ahead and sketch the graph. Good morning. The first of this has been recorded, so. Did you bring me breakfast?
Did you bring my donuts?
Did you get 100%? Did everyone get 100%?
No, we did not.
No. No.
Guys.
I got 100 today, ain't that right, Eddie? Yep. Silence is loud.
Yeah.
Silence talks.
It's quiet before the storm.
Work coach.
Okay, so then here's the parent graph.
It's time to go.
Yeah, what is that bell?
Is that
They're on yesterday's bell schedule.
Yeah.
Yeah.
Oh my heavens. Okay, so here's the parent graph, right? That's what the normal one looks like. Okay, so with my new one, I shifted it pi over 3. So where is pi over 3 on my graph? Where is pi over 3?
Like, it's
Right.
somewhere in front of pi over 2.
Because we know from the unit circle it's in the first quadrant.
Yeah.
So it's going to be just to the left of pi over 3, right?
right?
Okay. Now, what's my period?
Pi over pi.
Pi. Okay, so what is pi plus pi over 3?
2 pi over 3.
No,
I
Okay.
squared over 3.
no, you're multiplying. You gotta get common denominator, right? So this is 1, so that's the same as saying 3 pi over 3.
Oh, yeah.
So what's 3 pi over 3 plus 1 pi over 3?
4 pi over 3.
This equals 4 pi over 3. Where is that gonna be on my graph?
Like, in the third quadrant.
In the third quadrant, so somewhere around maybe right here.
Yeah.
So what that means is 4 pi over 3, from pi over 3 to 4 over pi over 3 is my period, and I'm going to make my entire cycle. I'm going to go to the max, to the 0, down to the min, and back to 0 between pi over 3 and 4 pi over 3. So my question is, how do I find the points in between them? So we take pi, and what did I do before? I took the period and multiplied by what?
1/4.
Is it always 1/4?
Yes.
Yes.
Yes, always 1/4. So it's going to be pi over
Say
4.
no.
Now, if you remember last time, I would graph at pi over 4 and 2 pi over 4 and 3 pi over 4 and 4 pi over 4. That would be my points. In this case, I'm not starting at 0. So how am I going to find the second point?
Common denominator.
I'm going to take pi over 3, and I'm going to add it to pi over 4. Because here's my new starting point. I need to add to it pi over 4 to get my next, where the maximum is going to be. So I'm going to get 4 pi over 12 plus 3 pi over 12, and I'm going to get 7 pi over 12. And 7 pi over 12 is not in the unit circle, is it?
No.
No, but we know it's just a little bit bigger than 1/2, so it's going to be somewhere here. 7 pi
Wait, so
over 12.
why'd you add, is that 3 pi over 12? Why'd you add that to 4 pi over 12?
Common denominators. So pi over 3, which is my starting point,
Yeah.
plus pi over 4, because that's the distance of the first quadrant.
Mm,
And then you add those together, you get 7 pi over 12.
okay.
How am I going to find the next point? This is pi over 3, this is 7 pi over 12. What's the next one going to be?
It's gonna be 11 pi over 12.
How did you get that?
I added
You added what?
4.
Okay, I'm going to add 7 pi over 12, and I'm going to add another pi over 4 to it.
Yeah.
Not,
Wait, no, not like that. Like 4 pi. I added 4 pi over 12.
yeah, that would be pi over 3. That's not what we're adding.
Did
Yeah.
I get that right?
No.
Oh.
You're going to add
Well, dang.
8 pi.
7 pi over 12 plus 3 pi over 12.
Something over 48.
Oh, so it's 10 pi over 12.
And reduce that.
So that's gonna be 5 over 6.
5 pi over 6. And that's on the unit circle, right?
Mm.
Yeah.
That's right before pi. It's right in here.
Wait. Oh, okay. Never mind.
So then this is going to be my 0. At 7 pi over 12 is going to be my maximum. At 5 pi over 6, it's going to be back to 0, right? Where's the next one going to be?
That's it.
No, we have one more.
Never mind.
We have one more, right?
Oh, it's gonna be, so you gotta add another 3 over
Three.
3 pi over 12. So
5
then you're
pi
gonna
over
get
6.
13. Oh.
That's what it is.
so 13 over 12.
13 pi over 12. So it's going to be somewhere in here, right?
Yeah.
And as I'm looking at my thing, it looks like I'm off a little bit. As far as the spacing,
Yeah.
we're close enough.
Rightfully so.
And then that's going to be the minimum, and then back to here. Whoops, the minimum is that, yeah. So then I have my graph looking something like that. Ooh. I tried.
Wait, so 1,
I tried to
2,
sketch it.
3, 4, 5. Why do you have 5 points?
We always have 5 points.
We do?
At this time, can we
Zero,
get the business
maximum.
students
Oh,
and
yeah.
Health Start students to the front lobby? Again, Health Start and the business students to the front lobby. Thank you.
So
I haven't been writing it, but we always have the first point 0.
Yeah, yeah.
Oh, yeah. Okay.
Yeah, 5 points, so you have 4 spaces.
Yeah. Got him.
So it's a different starting point, and then rather than this pi over 4, we have to add that to our starting point and make our spaces.
Okay.
And this is honestly why I kind of like doing pi over 3, and then marking 4 pi over 3, then half, and then half of each. That's the first method I showed you, and you all didn't like that, so you like this one better.
Yeah.
I kind of like that, doing it. Either way is fine. Okay, yes.
What's that number right there where it's like 2
Right
and
here?
that? Yeah.
That's out of 3.
Oh,
Because I factored out a 2, so it's left with pi over 3.
It's all recorded, right?
Say it again.
It's all recorded, right?
It's all recorded. Even that question you just asked.
You
And
can
my
go
answer.
on,
Even this is being recorded. See, even that question you just asked is being recorded.
Hi, YouTube.
Huh? Oh, you said hi, YouTube.
That's funny.
Kind of. Okay, we good? All right. You try one. Try another.
Excuse me?
Huh?
Let's go g of x. We're going to change something on this one, though. We're going to put in a 4. times the sine of, we don't want to make this too hard just yet, 4x minus 2 pi over 3. Seems to be the same, but it's not quite.
All right.
So this first 4 up front does what to it?
Amplitude.
It just changes the vertical stretch, okay? Still, midline still at 0, so it's gonna go up to 4, down to -4. Okay. Find the period and the phase shift.
Wait, so it just starts at 0 though, right? Since there's no D?
Yeah, the midline's gonna be at the x-axis, yeah.
Okay. So. 1, 2,
Damon, you got it figured out?
I'm still going.
So, did you get the period? What'd you get for the period? Yeah, yeah, okay.
It's pi over 2.
How did you get that?
The 2 pi divided by
So it's still the same formula. So 2 pi over 4. So the period is pi over 2. Yes.
How did you remove the 2?
How did I remove what 2?
The pi on pi over
2 pi over 4?
Simplify?
We're just talking about right here, 2 pi over
Yes.
4?
Well, when you
You divide.
oh.
2 over 4 just reduces to 1 over 2.
Right from the side.
Is that a B right there?
Is that a B right
no,
there?
the 2 pi over B.
Yes, that's the formula. I just wrote it in there to remind us that the period is always 2 pi over
So
B. So then it's 2 pi over 4. My apologies, I've got to get some.
wait, so we just multiplied the phase shift or the C by 1/2?
No, we only did it for that one because it was 2 pi over 3.
Why did we do that?
So we can cancel each of them out.
But why?
So we get the answer.
Okay, so how do I get the phase shift?
I don't know.
What, you said something equal to 0. Yes.
You said that whole thing set to 0, the
This,
parentheses.
everything in here. 4x minus 2 pi over 3. You set that whole thing equal to 0.
And then you solve for x.
You solve for x. So I'm going to add 2 pi over 30. So we get 4x equals 2 pi over 30.
And we divide
Divide by,
4.
okay, I'm going to multiply by 1/4. It's the same thing.
So like, what if we do divide? I guess that's
So if you divide by 4, you're going to keep change left.
okay.
Divide by 4, you're just going to multiply, keep, multiply, and then switch to 1.
Alright.
It's the same. I just like the way it looks better. So x is going to equal 2 pi over 12, which is going to give me pi over 6. Now, what is pi over 6? We've taken what's inside the parentheses, we've set it equals 0, So what? What is pi over 6?
Pi over 6 is in the first quadrant.
No. Well, it is in the first quadrant. But what is it?
Base.
It's the starting
Oh.
point. This is the new thing. This is the starting point. Which means rather than starting at 0, I'm going to start at pi over 6, which, yes, is in the first quadrant. I'm going to say approximately right there. Pi over 6. And the whole period is going to be within pi over 2 from that point, right? So pi over 6 plus pi over 2. That's going to give me the ending point.
You have to have a common denominator.
What's 2 pi over 12 plus 6 pi over 12?
So
8 pi over 12.
Which does reduce to 4 pi. No. It doesn't. What's it reduce to?
4 pi over 6.
Say it again.
4 pi over 6.
Which reduces down to
2 over 3.
pi over
2 pi over
3.
3.
2 pi over 3. And then 2 pi over 3 is going to be somewhere about right here. In the second quadrant, right? So the entire cycle to the maximum, back to 0, down to the minimum, back to 0, is going to happen in that space. Okay? How do I find the second point? My starting point is
You
pi
add
over
2
6.
pi over 3.
you do the 1/4 thing.
I got to do the 1/4
Oh,
thing.
yeah.
Because the whole thing is going to be, what's the phase shift? Pi over 2.
Yeah.
So if I multiply that by 1/4, that gives me the length of each little section. Okay. So if I start at pi over 6, I'm going to add to it pi over 8. It's going to tell me what the second point is. So what's pi over 6 plus pi over 8?
The common denominator again.
Is,
So
Be 24.
yep. So 4 pi plus 3 pi gives me 7 pi over 24, which is just a little bit bigger than pi over 4. So about right there. 7 pi. And once again, when you find these points, you're just kind of estimating. How do I find the next point?
do the same
I'll
thing.
do the same thing.
7 pi over 24 plus, what am I adding to it?
1/8.
So I'm gonna do what Cordell did and just leave with this one, because that's 1/8, right? So add 3 pi over 24. What do you get?
Right, so why did you
10 pi over 24.
Because I took 1/8, just use the one with the 24 that was on there.
You just do 10 pi over 24.
10 pi over 24. Which reduces to,
Really than 5 over 12. or
5 pi over 12. Yep. And I think we have to find one more. I'm gonna be off on my graph. How do I find the next one?
10 pi over 24 plus 3 pi over 24.
Plus 3 pi.
13 pi over 24.
Plus 13 pi.
So it's like
And you just keep adding that same 1/8. So we have 13 pi. And you just keep adding that same distance to each one.
What's the one that you added to 10 pi?
Say it again.
What's the one that you added to the 10 pi over 24?
Once again, you just added 3 pi over 24,
Oh.
1/8. You just keep adding that 1/8 to each one. All right, now to graph it, this was going to be a pretty crazy one. Because we're going to start at 0. At 7 pi over 24, what's its value going to be? What's its maximum?
It's maximum. Since you go up 4, it's going to be 4.
All up to 4. Back to 0. At 13 pi over 24, it's going to be at its minimum.
-4.
and then back to 0. We have a funky looking graph. Cool. Okay, so maybe not all the adding fractions, maybe not all the computation part, but does the concept make sense?
Yeah.
You find your starting point and then you just add that little distance to each one of them?
Yeah.
That concept makes sense?
Yeah.
Then at that point, it's just a matter of figuring out the fraction. If they were whole numbers, it'd be much easier. Fortunately, they're not. They're always going to be something about that. All right, scale of 1 to 5, where are you? On this whole graphing this.
Oh, like on everything?
On everything we've done.
It's like 4.
4, you ready for the test?
Yeah.
Okay. 3s we're ready for some independent practice. 2 need some more guided practice. Let's have you try one more. We haven't done cosine yet, have we? Haven't graphed cosine?
No.
Let's do it real quick. Let's just, so you see it, okay? You're gonna be amazed at how easy it is. Yes, I'm looking at you, because you're looking at me like I'm crazy. All right, what color do we want to use cosine for?
Pink.
Pink, okay. So let's just, don't do any math yet, okay? Let's just say, what if this was h of x equals 4 cosine of 4x minus 2 pi over 3? Okay, let's just say it was that. The difference between sine and cosine is the pattern. Sine goes 0, max, 0, min, 0. Okay? That's the, those are z's. That's the sine group, okay? Cosine goes maximum, 0, minimum, 0, maximum. Everything else is exactly the same. So to graph this one at pi over 6, where would I be? 4. I would be up here at 4. At the next point, where would I be?
0.
0. At this point, where would I be? Negative 4. Here I would have, and here I'd be back at, and there's my cosine curve. It's exactly the same, only you go in a different order.
This is so much easier.
The cosine?
Yeah.
Sine takes forever to learn. Once you get it, cosine's simple. Because you're just changing my starting point and where I'm ending. It's the same curve.
That just feels so much easier.
Well, you've done the work, of course.
Yeah.
All right, so we're not going to do cosine yet, but that's how it works. Okay. And I'll give you that max, 0, min, 0. If you haven't written it down yet, I'll give that to you again a couple times. It's just the order of where they hit. Okay. It's really kind of like the sine curve shifted pi over 2. Because this point starts here, this point is here, this point is here, here, and back. Boy, that was ugly. Okay, but you get the idea. All right, try this one. Let's do one on your own. Let's go back to g of x equals. Are you ready for more complex?
No.
Oh, so you don't want me to do the have a great day. Can I change the amplitude?
Yeah.
Can I change the midline?
Actually, you can change all of it.
Yeah,
Okay,
you
that's
just
what
change
I'm
all
doing.
of it.
I was
yeah.
planning on it. So -2 times the sine of 3x plus pi over 4 plus 1. Now, we haven't talked about it, but because that says plus pi over 4, which way am I going to shift?
To the left.
To the left. So I'm going to start on the negative side. Now, how far is up to you to figure out. Okay.
Does that mean we have to have like
Oh, wait, it's only going to be half.
whole,
So that right there is going to be pi over 2. And then this right here is going to be pi over 4.
Really? You're just going to have to come over a little bit.
Why can't I just put the origin on the right side?
Make a what?
And so like the line is going this way to the left, and so now it's just the same thing, but the origin's on the right side.
The origin? You mean
Or
like
the-
rotate it?
Yeah.
Well, you're still going to need, because this one's not going to go too far to the left.
Oh.
It's just going to be a little bit, then you're going to be.
Oh.
This is where it starts.
Well, yeah, I know that. I know where it's.
Yeah.
It starts right there, right?
How'd you get that?
Because it's just pi over 4 and then pi over 2 and then half. After that is pi over 4.
Remember, if you set this equals 0.
God dang it. I thought I was cooking. Am I close?
He said, how'd you get that?
I know, I was like, how'd you get that so fast? That's impressive.
Damn. How do you say this again?
Bro, so it'll be 3x plus 4, or pi over
3x plus pi over
4 equals 0, and then you'll do minus pi over 4.
4. Huh?
And
Wait, so minus pi over 4.
negative pi over 4, so it'll be 3x equals negative pi over 4. And so then we'll times it by 1/3, so 1/3 crosses out. And so we'll get 12 plus 4. So 7